Kia ora, everyone. It's my pleasure, myself, Gina, and Karen, to tell you our story of how we started this ADHD project. You know, I was just looking at the design of this symposium, these short 15-minute talks, and I was thinking absolutely perfect for ADHD people with short attention spans. Absolutely perfect. Okay, so as you can see up there, we have someone lying in a scanner. Okay, that happens to be me. It was one of the few times that I actually get to lie down on the job. It's great. And what I'm going to do is tell you about how we started to look at ADHD from a different perspective. And we decided to use MRI, and we decided to look at this phenomenon of fidgeting that's often associated with people who have ADHD. Before I start, people often put this at the end, but I think it's absolutely essential to acknowledge that such a project cannot happen without such a diverse group of people. And up here we have engineers, psychologists, psychiatrists, medical physicists, people from different backgrounds and different cultures. And that's why we were able to really make some impact in such a short period of time, getting together. And of course, the immense support from the Tairāwhiti community, who are our participants in this study. Now, if I was to say to you that people on the ADHD end of a spectrum move differently, would you be surprised? In fact, this is well known. In the literature, it's been shown that people with ADHD not only walk faster, but they have a different postural sway, postural instability, and they tend to walk with an increased anterior pelvic tilt. What does it all mean? Well, it means that generally when they stand, they tend to sway a bit like this. Okay? Also, when they walk, they have that, well, rather bad ergonomic posture, but that's what they tend to do. Okay? So these outward presentations, okay, must be a sign of something that they're doing, perhaps with a purpose. So then I'll bring your attention to that other kind of motion that you may be familiar with, and that is fidgeting. Okay, I'm sure we've all experienced people fidgeting on public transport, in classrooms. Okay, the idea behind fidgeting, and this idea came in the 90s, was that if you fidgeted with gadgets and things like that, then you concentrated better. Okay. However, the science on this is a little loose. In fact, there's a lot of literature out there to say that people who fidget, especially with spinners and gadgets like that, that actually may impede their learning. So what is this all about? So we actually set out to try and see if we could measure this objectively and try and understand why people who have ADHD tend to show more presentations of fidgeting. And what we did was we set up this MRI experiment. And the particular modality that we used, you heard about it this evening, is functional MRI. Now this is the work of one of our PhD students, Susan Zhao, up in the top left-hand corner there, or my left-hand corner. And what we did was we asked participants, okay, to concentrate on a screen inside their helmet and do a particular higher executive functioning task. So they were looking at these little arrows, and they were asked to click on the direction of the arrow in the middle. And this is a well-known test, and it's called a flanker task. What it does is it elicits the higher executive functioning in your brain, the prefrontal cortex. And what we saw using fMRI was increased activation in people who are neurotypical. What we also saw was those people who have ADHD, on the bottom there, had underactivation. Now this is an interesting finding, but at the same time, it was not surprising because people had seen this before. But what we saw next was the eureka moment for us, because we asked people to do that same test while fidgeting. Okay, now this is a challenge because in MRIs, generally you're not supposed to move, right? So what we did was we isolated the knee joint downwards by putting a little cushion, and we asked them to fidget their feet, because fidgeting the feet is a very common form of fidgeting. And this is what we found. Turns out that those people who are more neurotypical, around 70% of them had a reduced activation now while fidgeting. In contrast, those people with ADHD, around 2/3 of them showed increased activation with fidgeting. It's almost as if the fidgeting was assisting those with ADHD to concentrate, whereas those people who are more neurotypical were finding it more distracting. Perhaps this might explain why some of those earlier studies were a bit mixed in their outcomes. Perhaps those people who were fidgeting and had impeded learning were actually more on the neurotypical end of the spectrum. Okay? We also looked at what happens when you move away from your resting state. Okay? So if you look at that image in the top left-hand corner there, that is a functional MRI image of what your brain looks like when you're resting. And we call it a default mode network. Okay? Now, when you give someone a task to do, such as the flanker task, people move away from that resting state to another task network. What we found was that people who are more neurotypical, if you asked them to move away from their resting state, around 2/3 of them could easily do it. Okay? In contrast, those with ADHD, only about 1/3 or less than 1/3 could do that naturally. Okay? Turns out that people with ADHD love to stay in a resting state. However, when we asked them to fidget, on the right column there in red, we found that those with ADHD, more than 2/3 of them were now able to move away from their resting state and concentrate on that task. However, and very interestingly again, we found that those who are more neurotypical dropped to around 50%. Again, it's if fidgeting is more distracting for those who are neurotypical, and in contrast, for people who have ADHD, it's more assistive. It's almost as if people with ADHD fidget for a purpose. So what does this all mean to the psychologist, and what does this all mean to the clinician? And to explore that aspect, I'm going to invite Gina.
Just before I start, I just want to acknowledge two other people who are in my research team, Dr. Makarena Dudley and Mātua Full. So, as you can tell from the title of our presentation, Fidgeting as a Research Construct, it's pretty fundamental to our entire research design. And given fidgeting is something that everybody does, what makes someone more fidgety than someone else? And so a clear definition of fidgeting became critical. Usually fidgeting is one of those behaviours that everybody knows when they see it. So when someone fidgets, they say, hey, look, that's what it is. So from this very brief scenario, you could say that fidgeting is something that's physically observable, and it involves what's called micro behaviours of some sort of description. That might be finger tapping or toe tapping. So then you would would you then distinguish fidgeting from, say, something like a Parkinson's tremor or a vocal stim or a tic? Do these micromotor behaviours also qualify as fidgeting? Would you say they were the same thing? Well, fidgeting was first suggested as a potential research construct by Francis Galton. His article, The Measure of a Fidget, was published in Nature in 1885. Now, what is critical in the early research is that Francis not only confirmed that fidgeting involves micromotor behaviours, but he also identified fidgeting as something triggered by contextual factors that are under an individual's complete control. Now, this is an important distinction because you may not realise you are fidgeting, but if I asked you to stop, you are able to stop upon request. So if we go back to my original list, this takes Parkinson's tremors out of the fidgeting category, as these tremors are uncontrollable and independent of context. This hypothesis also takes tics out of fidgeting category because even though they can be triggered by contextual factors, they are also compulsions, so they're not controllable by an individual. So what about vocal stims? Don't vocal stims involve some type of motor behaviour? Well, yes, they are triggered by contextual factors, and yes, they are controllable by an individual, but because we can only hear them, we can't see them, does that make it a fidget? So, based on vocal stims, do we need to go back to Francis Galton's original hypothesis and say maybe we need to extend what it means to fidget to include things that we don't see? It's not just micromotor movements. So I'm sure you're all sitting there thinking to yourselves, why does semantics matter, Gina? Like, why do we need to know that? So I'm glad you asked. Well, for me personally, yes, it does matter, because my kaupapa has always been, how can research help people, my community? That's my driving ambition. As a clinical psychology student from Tairawhiti, helping this research team to develop a clinical application of fidgeting is how I can best meet my kaupapa. In clinical practice, a distinction is made between signs and symptoms. So, signs are observable by a clinician, whereas symptoms are aspects of a patient's subjective experience. For clinical psychologists in New Zealand, our practice around symptomology is primarily determined by the American Diagnostic Statistical Manual, it's a mouthful, or the DSM. We're up to the 5th edition, now called the DSM-5-TR. So ADHD is one of the founding disorders of the very first DSM edition, and fidgeting was identified as its very first symptom. That's an impressive whakapapa. One could argue, therefore, that fidgeting is a tupuna for clinical symptomology, and as a tupuna, you would expect fidgeting to have children and mukapuna. Well, fidgeting as a symptomology was first only associated with ADHD. However, over each successive DSM edition, it has grown and changed names as it has married into other disorders, such as restlessness, psychomotor agitation, psychomotor retardation, and agitation generally. All of these symptoms and signs can whakapapa to fidgeting. So fidgeting is now also related to depression, BPD, anxiety, OCD, autism, and addiction disorders. This is why it is important we need to define fidgeting to assist in more accurate diagnoses and differential diagnoses. And we need to be able to measure fidgeting so that we can use fidgeting as a barometer to monitor overall mental health wellness. This has never been done before. And this is how I did it. By using unstructured observations and online community forums, I identified a range of habitual fidgeting behaviours across a wide range of diverse clinical populations. I confirmed Francis's initial hypothesis that fidgeting includes a contextual dimension. A questionnaire battery was then developed, and the next stage involved testing its validity and reliability for use in clinical populations. 1,685 online Reddit participants filled out the battery. Item response theory was used to validate the battery for clinical use and for use in research. This slide here shows the results only for the ADHD population, but I had PTSD, OCD, anxiety, major depression, BPD, and other disorders. The red triangles are the clinical group, and the black triangles is the non-clinical group. What this tells us is that there is a distinct separation between clinical and non-clinical groups in terms of behaviour, but not their context. What this means is that a clinical sign is going to be more telling for ADHD people than their subjective experiences. So based on these validation results, Whakarorerore Ara Mātai was born. Whakarorerore Ara Mātai defines fidgeting as a valid and reliable research clinical construct in the following way. Fidgeting is made up of 2 primary dimensions. Hopefully I can do this. Never mind. Fidgeting is made up of 2 primary dimensions, context and behaviour. Behaviour has 6 secondary dimensions and context has 8. Each secondary dimension has sub-dimensions ranging between 3 to 9 items. Participants fill out the Whakarorerore Ara Mātai, and then we implement the research design Justin just talked about. So how do we pull this all together? What's important to notice from this graph is that our research design utilised the Erickson flanker task as a proxy to measure higher level thinking that Justin also called executive functioning. The Erickson has been around since 1970, and it has a massive amount of literature to support its use. This graph tells us that we use the Erickson correctly. We say, and if you were writing it up, we would say something like, we successfully replicated the literature trend. What we can show a congruency effect. Congruent means easy, and incongruent means hard. The taller the graph, the longer the reaction time. This makes sense, right? This graph is saying that no matter whether you're ADHD or whether you're neurotypical, you will take longer to solve a harder task than an easier one. So that's not rocket science, but we needed to show that we didn't have any confounds. What this graph does show is that ADHD group take longer to solve tasks, whether easy or hard, than the non-ADHD group. Now this graph is actually seriously cool, which is just confirming what Justin was talking about. So what you can see here is the breakdown between the two groups in terms of incongruent and congruent tasks, the easy and the hard tasks. And so what we can see here is that there is a significant difference when participants aren't asked to fidget. You can see that the reaction times for the ADHD group are much higher, significantly higher than the neurotypical group. And then what you can see is that when we allow them to fidget, that difference in reaction time between the two groups actually becomes insignificant. So that's a pretty cool finding. So what we have here is the fMRI bold activation for ADHD, but not in the neurotypical group. And so that just confirms what Justin was saying earlier in terms of reaction time. This is quite an interesting graph. Alongside the Ericsson, we also got our participants to complete what's called a Connors performance task. And what we can show is that there is indeed a relationship between the Connors performance task, the Ericsson flanker task, and the fidgeting and non-fidgeting like reaction times.
Kia ora koutou. My job here is to wrap up our session on the ADHD puzzle. I'm going to compare our findings with other findings in the field. I'll talk a little bit about the implications of the findings and mention future steps. So ADHD, attention deficit hyperactivity disorder, is only one of a number of neurodivergent conditions. And others include things like dyslexia, dyscalculia, dyspraxia, autism, and so on. And I'm interested in both the cognitive and biological markers of neurodivergent conditions. And in the case of ADHD, the main cognitive difficulty is thought to be due to poor executive functioning. And by that, we mean things like planning, allocation of attention, inhibition, self-regulation, working memory, sustained attention, and so on. Part of my research is analyzing data from longitudinal studies, like the Dunedin study, as Graham introduced yesterday. And my collaborators and I have found, for example, that ADHD symptoms can appear very early. They typically remain quite stable, and people usually don't grow out of their symptoms. We also know that there's lots of comorbidity with both other neurodivergent conditions and with mental health concerns like depression and anxiety. And finally, both genes and the environment, particularly the pregnancy environment, are both important for us to better understand the etiology of ADHD. So the other type of research that I do is experimental, so things like EEG and fMRI. But when I first got my job at the University of Auckland in 2001, brain imaging was at its infancy, and New Zealand didn't have an fMRI scanner. So some of my colleagues and I from psychology, we were fortunate to win a Vice Chancellor Development Award, and we were able to go to Melbourne to the Brain Research Institute and spend a few weeks with all of our graduate students, learn all about fMRI, designing experiments, and analyzing the data. And I was particularly excited about findings that I might have, because I had spent the last 2 years in New Zealand from Canada with my colleagues, friends, and even teachers saying to me, oh, we don't have dyslexia here. Or, you know, ADHD isn't real, it's just kids being rambunctious. And meanwhile, I'd spent the last 3 years of my PhD in a specialized school for neurodiversity called Foothills Academy. I'd spent a year of a practicum at a nonprofit learning center, learning how to assess kids and help remediate them. And so I was pretty sure that these conditions were real. And I also had a big body of research to back me up, showing that there's both structural and functional differences between those with ADHD and neurotypical people. And then New Zealand quickly caught up to Australia by having fMRIs all over Aotearoa, and there's me rocking a really interesting hairdo at the Camry in Auckland. So back to that first fMRI study, and my focus was on dyslexia, and so I was looking at a language task called a lexical decision task, and you had people in the scanner decide if a letter string was a real word or not. And for our neurotypical group, and I can't seem to work the laser either. Is it not working? It's not working. Anyways, where it says neurotypical readers, you see in the left hemisphere this great 2 blobs of activity that's involved in language, and we heard from Katie yesterday what those were. But what was quite striking was this also in the middle of the brain, in the prefrontal cortex, an area called the cingulate gyrus, where, as you can see, the typical readers had all of this activation, and it's because they were doing a decision-making task. And when I looked at the group with dyslexia, it didn't have as much of the language activation, but it certainly had the prefrontal activity. Now, in the far right brain was the group with ADHD, and it was just so striking that you just have no activation in that prefrontal cortex. And it's thought to be due to neurotransmitter depletion. And many people think of ADHD more as a dopamine deficit disorder. And some research that I've done does show that's why our stimulant medication works. So drugs like dexamphetamine and Ritalin do normalize the brain, increasing the activity in the prefrontal cortex. And as we've just heard from Justin and Gina, fidgeting, which I could love to show you how I could circle that. It's a big part of the diagnostic presentation of ADHD, as Gina mentioned here. Now, if fidgeting can allow us to focus and flourish during resting and tasks, it really should be celebrated and certainly not penalize our tamariki in the classroom, for example. So that's our main message, that fidgeting is something that is a positive step. And it also our next steps are to look at children next year in the scanner. And there's two things that allow us to make that possible. The first was the Marsden grant that was mentioned. And the second, very clever people at Mātai and our PhD students and others have discovered ways to make that scanning time much reduced, and that allows us to scan children, and particularly those with special needs like ADHD. So, why is it important for us to assess children? First, it might help with earlier identification and treatment, and second, it is, it might help with the stigma and negative connotations surrounding neurodiversity. And I'll finish off with a slide that kind of showcases my 15 seconds of fame after many more fMRI studies and talks with the Ministry of Education. The government finally recognized that dyslexia does indeed exist. Yeah, thank you very much. And this and also all of the research we've heard in the last couple of days really gives me hope and assurance that the research that we are doing does make a difference, that we're making lives better. Thank you.